Oh, hi. Let's do some martial art, okay? Yeah, let's fight off the coronavirus, okay, so to speak. All right. Whew. Yeah, I'm not that good at it. Whew. I think that's enough, so. Wow. Let's do some knees, right? How about that? Oh, good enough. Whew. Oh. Okay, we're back. So, all right. Let's go ahead and do just a little bit more about this. And I probably write this down because uh, okay, so we got some result here. It's time to interpret this. What this means. Uh, this is nice formula really. It gives us some idea regarding this set of binary strings. How big is it compared to n numbers? So we have n by n matrix, okay? Currently 8 by 8, all right? So the vertical size is n, okay? Wait a minute. That's an easy way to do this, right? I mean, you have string that's length n. How many binary strings are there? 2 to the nth. Yeah, maybe it wasn't that necessary to come up with we derive this formula, but hey, whatever. I'm like, oops, all this for nothing. Hey. That was really dumb of me. Oh boy. Tunnel vision, right? Yeah. I thought it was a nice exercise, wasn't it? Having this oops moment as opposed to aha moment. Well, let me take a picture of this. That was really dumb of me. Why didn't I think of that? There's a song about that, right? Why didn't I think of that? So, basically that's the point, okay? Uh, the when so you have binary string, okay, of size n, all right? So how many binary strings are there? Yeah, 2 times n times, 2 to the nth, okay? Oh man, why didn't I think of that? So roughly speaking, okay. By the way, mathematicians do deal with infinity. I kind of forgot about that yesterday. It's about big O notation. Okay. Also in computer science too. Okay. Big O notation is kinda how to calculate infinity. Kinda. Okay. If you're interested, yeah, go ahead, look it up. Big O notation. Also, there's small O notation, but that's not commonly used. They typically use big O notation. Okay. Or probably O stands for the order of magnitude or something like that. Okay. You get polynomial time, exponential time, logarithmic time, or n log n time, log n, log n time, all that stuff. Okay. It's used for calculate the efficiency of an algorithm. Okay. Asymptotic behavior, how as input grows, uh, how does this particular algorithm perform? Okay. Yeah. Now, so this diagonal method by Herr Cantor is basically it's basically that. Okay, so integer, I mean natural number grows, right? And then so we can think of it that way. Okay, so kinda. Okay, so when think of it this way. Okay, so you have n by n matrix. Okay, so uh, binary string in each row, it's length n. Okay, n columns. Now, then the kind of variation. Okay, so the number of binary strings of length n is 2 to the nth. Okay, so that's about the size of this guy. Okay, so most likely the size of this set of infinite set, because we are sending n to infinity. Okay, we're sending n to infinity. Okay, so let's formalize that, shall we? Okay. I'm not ready to erase this yet. Okay, so we're gonna grab another whiteboard. Okay? Let me put some layers on. Kind of getting chilly. It's some new way to look at Cantor's diagonal method from kind of like computer scientists' approach. I mean, perspective, kinda. How about this? How about we'll analyze, we'll give it a new twist, kind of new direction, new angle of analysis from a former computer programmer's perspective. How about that? That's kind of pretty formula, by the way. Yeah. Anyways, so let's formalize this. Your binary strings, set of binary strings. Okay, so uh, for example, we call it B1. And a black pen. Set of binary strings with length 1. Okay? B2, set of binary strings of length 2. Okay? Now, dot 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 Bn contains all the binary strings with lengths n. Okay? Absolute value, yeah, 2 today, n. Okay? Now, so alpha is an infinite number and it's kind of more standard infinite number because it represents the size of countable set, which has one-to-one correspondence with natural numbers, natural number set. Okay, so it's this. We'll say alpha is. What I'm saying is set of positive integers, natural numbers. We call it alpha. Okay. Now, so then B alpha is set of infinite set of binary numbers with infinite length, and that infinity is particular. There are different kinds of infinity. Okay, that infinity is alpha. Okay, in Cantorian diagonal method. Okay, so and what's the absolute value of that? Yeah, it's 2 to the alpha. Okay, so yeah, good, very good. Of course, that's bigger than alpha, which is the cardinality of natural number. Okay, now we know what it is. This is fairly significant result. Okay, yeah. And it took us a long while to get here. We didn't have to drive that kind of bulky formula, but we got it, all right? So yes, congratulations. Okay, let me write this down. Wait, this is something really cool. Okay, so we solved this problem. Okay, so yeah, kind of informal proof of uncountability of this Cantor's infinite set of infinite binary strings. Okay, so yeah, this is exactly what that is. Okay, so and we had this purpose and goal objective, right? And we did it. We expressed the function. Okay, the b set at cardinality. We wanted to express that in terms of alpha, right? Yeah, it's 2 to the alpha. We have it. Okay, very cool. Very cool. So how was your day? Yeah, I had a very good day. Yeah, living life as normal. So good, very good. There we go. We'll take 5 minutes break, and I'm gonna let's take a second look at this. This is correct, okay, but let's make some examples and just for fun, okay. And we might get back to gold box conjecture a little bit. Why? Uh, I kind of miss it a little bit, just a little bit. Okay, so just a little bit. Okay, all right. Let me take 5 minutes. Let me take a picture of this. Okay, where did I put my glasses? Okay, let's have some fun. So, how about because what some of the questions that Mr. Gero Cantor had Cantor asked himself is the well, one interpretation of what he did is that relative size of different infinite sets. Okay, and now that we are equipped with this infinity algebra, kind of standardization, we came up with some kind of unit. Okay, so the unit of infinity. Okay, so let's go ahead and calculate the size of infinite set of rational numbers. Okay, I think that'd be interesting to think about. Let me drink a little. I'm kind of excited about this. Okay, because this is interesting problem, really. Theoretically speaking, it's very intellectual, entertainment, recreational mathematics kinda. It gives a very good break to good box labor, right? Yeah. Did I take a picture of this? Yes. Good. I'm gonna start drinking, okay? Because I'm kind of excited about this, and everything that Mister, as far as I know, maybe he used this alpha concept using different letter like Hebrew character. I don't know any Hebrew, okay? So I know a little bit of Arabic, and I know they are quite similar, but their alphabet is different. Okay, so and I don't know how far he got when it comes to this cardinality theory. Uh, Maybe I'm repeating what he did. I don't know. Okay, but whatever. I don't have time to study his theory. Okay, so yeah. I mean, we may be reinventing the wheel, but so what? We just want to have fun. Okay. Okay. All right. We also know that fraction set, right? Fraction set, set of fractions, n absolute value of cardinality, size of the set, and divide by fraction, okay, and divide by f is f times alpha, right? Yeah, we know that much. Now, so what is rational number? Rational number is a number. We are only going to deal with positive number. Okay. Also, we also know set of order integers is absolute value thereof 2 times alpha, right? Yeah, we know that much. Okay. Uh, Rational number is any number that can be, and don't care about negative number. Okay, it's just multiply twice two, then that's it, right? Rational number, positive rational number is a number that can be expressed as a fraction of between two natural numbers. Okay, that's what rational number is. Okay, like 1/3, 2/5, that kind of stuff. 1/7. Okay, so set of all rational numbers is this. Watch. We don't need this anymore, so let's erase it. We don't need anything. Okay, so set of rational number. I think they use the symbol Q. Okay, rational number set is equal to union f from 1 to infinity, but it's alpha. Okay, okay. Uh, Before that, I forgot. Okay, so you have B1 set is what? 0, 1. B2 set, right? Dot, dot, dot. And your B alpha is, you have 0, 0, dot, 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 0, 0, dot, 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 dot. And the size of this infinity, we call it alpha. Okay? And then the last element will go something like 1, 1, 1, dot, 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 1, 1, 1, dot, 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 1, 1, 1, something like that, right? So, how many rows are there? 2 to the alpha. Okay, so that's what it means. Okay, so absolute value of B alpha is nothing but number of rows. Okay, all right. So that's what it is. And Mr. Cantor only proved the inequality that alpha, I mean 2 to the alpha is bigger than alpha. Okay, alpha means alpha is the size of countable set. Okay, yeah, it's bigger. It's not the same. Okay, so that's one way to look at Cantorian diagonal proof. Okay, and now we know exactly what that number is. It's 2 to the alpha, which is by of course bigger than alpha. Okay. Yeah, we proved equal. We kind of conceptually proved the equality as well. Okay, not just inequality. I think that's where Mr. Cantor stopped. Okay, we picked it up. We picked it up where he stopped. Okay, so we basically continued his legacy, kind of inheritance, kind of descendant of Abraham kind of concept. Okay, metaphysically speaking. Okay, I think he was partially Jew. Okay, I'm not Jew at all. I'm 100% Asian. Okay, Korean Asian. So, but metaphysically speaking, yeah, long lineage of mathematicians, true mathematicians. Okay, okay, so that's that. I should write this down. Yeah. Yeah, it's very inspiring diagonal method. Okay, so we are not interested in this like undecidability, unprovability. No, no, no. If we cannot prove something given a language, what do? We expand the language. I know, yeah, the Gödel's incompleteness theorem. It says like, yeah, if you expand the language, then there's another problem kicks in. Well, it's beautiful theory. I get it, but we are not pessimists. We are optimists. Okay, we find a way to prove something. Okay, if the existing language doesn't prove it, we're gonna expand it. Okay. Gödel's incompleteness theorem that says like, yeah, if you introduce brand new axiom, then another problem arises like you may your so it's about completeness versus soundness. Okay, the Gödel's incompleteness theorem, in a nutshell, is like you have this system of axioms. Okay, so and later on there is some true theorems, true equations that is true, but you cannot prove with this set of axioms like piano arithmetic whatever. Okay, but if you introduce more axioms, you may able to prove that true equations. But so it'll be complete. But you introduce unsoundness. You will also be able to prove an incorrect equation. Okay, so that's Gödel's incompleteness theorem. Okay, but yeah, I mean like it's beautiful theory. Okay, I give him credit for that. But we don't really care. Why? Because we'll find a way. We are optimists. We're not pessimists. Okay, so okay. All right. Okay, so let's see what this looks like. Okay, so because I'm kind of wondering if is there any intersections. So this is like if you spell it out, this is like n union n over two union n over three union n over four. Okay. And what is set n? 1, 2, 3, 4, 5, 6, 7, 8, n over 2. Oh boy. N over 3. Systematic enumeration method, okay? That's what we're doing. Why? Because it always works. N over 4. Okay. Yeah, there are some intersections. You can tell. Now, before we get through this, and before we continue this, let's observe one more thing. Okay? How about the set of multiples? What's the cardinality of that? like say m for multiple, okay, m times n is a function of alpha, okay. Can you find this function? That's my quiz for you. Homework. Okay? Express cardinality of this set of multiple set, in terms of m and alpha. I'm sorry. Okay? Find the formula for that. Alright, it will take 5 minutes. Very good. This is so easy, right? And it's also interesting because it's brand new. But it's very easy problem, okay? How interesting. Okay. Yeah. Okay, you know what? Let's be politically correct. Okay. Because Arabs, they are also descendants of Abraham as well. And there's some, according to Middle Easterns, Muslims, there's some dispute about who was the wife of Abraham and who was the concubine of Abraham. Okay. That's long time ago, right? So you cannot quite rely on Jewish Bible because when they write their history, they are biased party. Okay, so uh, we don't know for sure. You have what, two sons of Abraham, right? Uh, Isaac and the other guy's name I don't recall. Okay, but the other son of Abraham, uh, according to Bible, they became the ancestor of the brother of I mean brother from different mother of Isaac. Okay, he became the ancestor of Arabs according to Bible. Okay, I don't recall his name. All right, but let's look him up. I mean, what's cell phone for, right? The knowledge of the world is in our hand, in handheld cell phone internet. Ishmael, Ishmael. Yeah. So yeah, Arabs they are descendants of Abraham as well, right? So who later on became some of them became like algebraist. Algebra, yeah, is Middle Eastern. Okay, it's not Jewish at all. Okay, when it comes to mathematics, Jews they learned mathematics from Europeans, who, according to Bible, like heathens, Gentiles. Okay, but Arabs, like including Egyptians and their neighbor like Greeks, they are the one who came up with mathematics like geometry and algebra. Okay, later on, yeah, Caucasians, Europeans, they learned from Greeks and Arabs, and they developed further. Okay, but mathematical descendants, they are more like Arabs, Middle Easterns, not Jews. Okay, so and Arabs, they are still descendant. In mathematical speaking, they are actually truer descendants of Abraham, mathematically speaking. Okay, so yeah, true story. Okay, Mr. Gary Cantor, he's just I don't know how much percentage Jewish he is, maybe partial Jew, I don't know, but his ancestor migrated from Israel, Middle East, Israel to Europe at some point, and he learned mathematics from Caucasians, Caucasian Europeans. Okay, so it's kind of like yeah, it's yeah. Anyways, but he's a very good mathematician, by the way. Okay. Yeah, but mathematics was developed by originally Arabs. Okay, Middle Easterns like Egyptians, Greeks, Arabs, Middle Easterns. Okay, algebra. Okay, that's like the zebra. What's zebra mean? I forgot. Let me look it up again, just one last time. Okay, so no, it's not gibberish. No, I'm just kidding. Okay, algebra does mean something. Repair. Okay, interesting. It's the actual word. Okay, it means like repair. All right, the repair, reparation. Okay, redress. Okay, okay. I don't know the story behind it, but Yeah, it's no brainer, right? Yeah, it gets sparser and sparser, less denser. Alpha over m. Okay, so it's that simple. All right. Okay. And later on, can we calculate the size cardinality of irrational numbers, like square root of 2, cubic root of 5, that kind of stuff? Yeah, yeah. It shouldn't be that difficult. Why? Because it's all about systematic enumeration. Okay, so yeah, we'll get to that. Okay, yeah, but one step at a time. It's yeah, it's kind of a pattern recognition kind of method. Okay, so yeah, I'm being overheated. Let me turn off the heater. Okay. So the cardinality, the size of Q set is size of this. We gotta get rid of all the intersections. Okay. And we know what the size of all this is, right? It's a 2 alpha, 3 alpha, but we have 4 alpha, but we gotta get rid of all the intersections. Most likely using this concept of multiple sets, or a set of multiples. Oh boy. And we may run into some problems of primes as well. Yeah. Okay. So. Okay. Let's take it easy. Take it nice and slow. All right. I don't know how difficult this problem is. I'm guessing it shouldn't be that difficult, but it's bulky. It's not qualitative, but quantitative kind of problem. Okay, it's not a difficult problem, but there's a lot of steps to get that formula. Okay, what we want to find is absolute value of Q expressed in terms of alpha. That's what we are looking for. Okay. Okay, I'm kind of getting it. So in this example, for instance, uh, we know. We'll look at this guy. Okay, 3. We know we also know there's some intersection, right? 3 over 3, 6 over 3, 9 over 3, that's just 1 to 3, which is already included in this n over 1. Okay? So we don't want to double count them, right? So, okay. What we are saying is this, okay? So, n union n over 3, absolute value thereof, okay, is just classical set theory, right? Right? What is this? You have like n intersection 3 n over 3, right? You have this 3 over 3, 6 over 3. It's like 1, 2, 3, 4, 5, 6, 7. Okay, so that's alpha. Because this is this guy is just um, shadow band. Okay, so this becomes 3 alpha. How interesting. That's unexpected. Okay, well, looks like there's some absorption rule here. Okay, yeah. N intersection n over f is equal to n. It should be, right? Yeah, okay, okay, okay. Mm-hmm. Okay, okay. I get it. So then intersection doesn't matter, right? Because okay, okay, okay. Maybe it does. I don't know. How about this guy? 4. Yeah, because you have 1 over 4 and then 2 over 4, which is equal to 1 over 2, right? But if you unionize this guy and this guy, then it gets absorbed, right? So okay, 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 okay. Do we have intersection between the third one and fourth one? Hmm. Do we have intersection between the second one and third one? Yeah. We do. No. 1 over 2. I don't think we do. Actually, we do. 3 over 6, I mean, 6 over 3 is equal to, that's 2, that's equal to 4 over 2. Okay, 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 okay. Okay. How interesting. By the way, this dot dot dot. Okay, the infinite sets. How interesting! This is an interesting problem. Okay. Yeah. Very nice break from gold box problem. Oh boy. We're gonna do it in a successive manner, okay? Because union operator happen to be commutative and also associative. Okay, so ordering doesn't matter. We unionize these first two guys, and then unionize with three, and then unionize this chunk of union with the fourth guy. Okay, we're doing a successive manner. Why? Because union operator, if you don't do it that way, it becomes very complex. Okay, a like a plus b plus c minus ab minus bc minus ca plus abc. Oh, it becomes a nightmare. Okay, so let's take 5 minutes. Okay. How interesting. Okay. Hmm. Yeah. We get back. Okay. You're gonna have to grab another whiteboard, alright? So let's go grab it. Alright. In the study of Goldbach's conjecture, we ran into this diagonal method. So that's how we got here, alright? So just tracing back the memory lane. Alright. We have some lemma, okay? We'll conceptually prove it, if not formally. Alright, we'll informally prove it, okay? So it seems four is multiple of 2, okay? So it seems like this subset. That's what it seems. It's a hypothesis, right? We go ahead and prove it, okay? Let's look at some pattern, okay? Mathematics is all about pattern, repeating pattern. Okay, you make example, and if there's some recurring pattern, and then you come up with a hypothesis, and you prove it. Okay, so that's how mathematics is made. Okay, so yeah, this is very educational here because we are not just giving you result. I mean, I mean you and me, Holy Spirit, sure. Okay. We are also showing you how mathematics is made, how science is made. Okay, so that's why this is very educational because we want to be, if not scientists, at least independent thinker. Okay, so as opposed to just giving you fish, we want to give you the fishing pole. Okay, so kinda. Okay, that's from Talmud, I guess, right? Yeah, yeah. Jewish tradition. But let's not forget about Arabs. Okay, so they're brothers. Okay, so we are brothers. Okay, let's make some example. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So that's n. Okay. Okay. One over two, yeah. 2/4. 2/2, yeah. 4/4. 3/2, yes. 6/4. Okay. 4/2, yeah. 8/4. Okay, because you just multiply both numerator and denominator by 2, then you get it. Okay, 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 okay. All right. So, how about the relationship between the absolute value? I mean, Of course, this is bigger. We know that, but because it gets denser and denser, more fine grained, right? But we want to find out some equality equation. Okay, what's the relationship between the two? Okay, well, because we know it's subset. Okay, so uh, okay, let's just unionize them. Okay, and see what we come up with. And because n over 2 is subset, right? Intersection is the smaller set. Cancel out. Okay, okay, okay. Yeah, it's easy. I told you it's easy problem, but it's quantitative, not qualitative. Okay, there's a lot to it, a lot of steps. All right, so I mean, this absolute value, not parentheses. Okay, okay, all right. Very mechanical. It doesn't take too much creativity. All right, but Goldbach's conjecture, yeah, that takes tremendous creativity. Prime numbers, right? It's not a mechanical process at all. Okay, but here, yeah, it is mechanical. It just takes time, diligence. Yeah. So we are using different parts of our brains. Okay, creativity versus just diligence. Okay, prime number, that's creativity. Okay, a lot of thinking, right? But everything else in mathematics, that mechanical, it's a lot of writing. Okay, so it's more physical level as opposed to, it's more like brain versus brain, physical versus metaphysical. Okay, so that's why I joined the U.S. Army as a junior elite soldiers. Okay, soldier because computer programming is brain intensive. Okay, but junior elite soldier in the U.S. Army more brain intensive, more physical labor. Right, so yeah. Because I wanted to give my brain some breaks. Okay, so yeah. Okay, let's analyze this. All right. Okay. So we use fraction, but yeah, fraction. Okay. So n over some number f. All right. It always belongs to no, 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 divisor. All right. Some divisor. Okay. And multiple of this divisor. Okay. Yeah. It goes like that. And then okay. Yeah. We're not gonna prove it, okay? Why? Because it's just too obvious, and we don't have time to prove all these lemmas, and no, we just assume it's true, okay? Why? We'll let some other people do, or I'll let you do it. I don't have time for this, okay? So, okay, go ahead, prove all these small lemmas, theorems, and publish it, okay? Because I'm not going to, all right? If we prove Goldbach's conjecture, yeah, unless you publish it first, yeah, I will try to publish it. Okay, it's something big, but this something minor. All right. Okay. Yeah, it's kind of absorption rule. Okay, so okay, so it does have to do with some prime numbers, right? Yeah. You have multiples and you have primes, right? Composite numbers and primes. Hmm. What if this number is 6? 1 over 6, n over 6, like 2 times 3. How do you deal with that? Ah, okay. So eventually, what we want to show is this. Okay, what we want to find is cardinality of Q. Okay, is equal to cardinality of n over 1 union n over 2 union n over 3 union n over 4 union n over 5 union n over 6 union n over 7 union dot dot dot. Okay, so and what we observe is this absorption. Okay, so we should take advantage of that. Okay, because 2 is multiple of 1. Okay, we can get rid of this guy. Right now, because 2 4 is multiple of 2, we can get rid of this guy. Okay, okay. So prime numbers that disappear, huh? Okay. Our hypothesis is this. Okay, it becomes set of all composites. Like, yeah, 4 is the first composite number, right? Right. Okay, which is equal to set of all this n over natural number minus set subtraction minus set of n over all the prime numbers. Okay, that's what it seems. Interesting. So yeah, we still have to deal with prime number. I try to avoid dealing with primes, but looks like it's inevitable. Okay, so okay, well. How interesting. I mean, we have prime counting function, right? Right? Yeah. Pi and this prime number theorem, right? Prime counting function that other mathematicians proved. All right. So, hmm. Okay. Do we have closed form formula for prime number and prime number? I mean, in 200 lost episode or before that, I kind of tried to do that, and we kind of came up with that, but it involves the inverse function of prime counting function. Okay, so it's kind of cheating a little bit. Okay, so uh, it's not quite algebraic closed form, but conceptually closed form. Okay, so okay. We'll take 5 minutes break, okay? So we'll keep thinking about this, okay? And we'll take 5 minutes break, okay? And then I'll grab my cell phone and take a picture of this, okay? You can see this, right? Yeah, it's pretty. So I'll take a picture of this. So all these primes, okay, gets observed, including one, because Goldbach's Euler's day, one was prime number, okay? So yeah, all the primes, including one, they get absorbed by the composites. Okay? Okay. Yeah, this subset. Maybe we should prove this guy, this lemma. Alright? Just show the world that we are able to prove something, right? I mean, back in the days when we were dealing with pyramid numbers and Euclidean triangle, yeah, we did a lot of proofs. Okay. It's been a long time since we proved anything, so yeah, we'll go ahead and do it. We grab brand new whiteboard and we prove this guy. Okay? Just to show the world that we are capable of proving something, okay? So okay, okay. Just to refresh our proving skill, alright? Every now and then, yeah, you gotta practice the skill, right? So as to not lose it, alright? Yeah, we go ahead and prove this guy. Okay? Yeah, sounds like a plan. Alright. Yeah, go ahead, look at it if you want, think about it, okay? So. Okay. Okay, we are back. Let's take a picture of this. Okay, uh, it's pretty. Okay, we prove it. Okay, so. Uh, yeah, we go ahead and erase this guy. Okay, so. Alright. So I never get sick. Why? Because if I feel something on my throat, I just pop in one day kill pill. Okay, trick along from my friends, right? And also I do healthy diet and regular exercise, right? And personal hygiene, yeah. Social distance. I've been practicing all those things always. Okay, so I never get sick. Okay, so and yeah, temperature control, right? Layers of clothing. Okay, yeah. So I never get sick. Okay, so all right. And martial art it strengthens the spirit. So yeah, right. Yeah. So many governors, mayors, political leaders, they close down the parks. I think that's a big mistake. Okay, why? They do so because they don't understand science. Okay, so in order to strengthen the immune system, okay, you have to exercise. Okay, what do they know? Scientifically illiterate, right? Scientists not giving very good advices, right? Because they're afraid. Okay, they're not quite leadership material. Scientists, politicians, and yeah, politicians they're scientifically ignorant, and scientists they're not leadership material. Okay, they are just afraid of the mass, the mainstream majoritarian people. It's about diet and exercise. Okay, but they don't want to offend anybody, so closing down the parks, big mistake. Okay, closing down the entire state, city, to stay at home. They don't know what they're doing. All right. That's why I'm running for Alaska State Senate and I'm also running for federal presidency. All right. Because these leaders, they're scientifically illiterate. All right. Oh boy. They don't know what they're doing. Okay. So. Okay. Let's prove this thing. All right. So. Okay. Okay. Hypothesis. All right. Okay. Given. All right. It's some divisor, some multiplication factor, right? So okay, let's look at the pattern over there, all right? So okay, here's proof, all right? It's been a while, okay? So it may take also a while, okay? Since we proved anything here, maybe a year ago, I don't know. Okay. Yeah, we have to use juxta notation, okay? Comma, 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 okay? Alpha, yeah, 1 to infinity, but it's you're doing counting fashion, countable set, 1, 2, 3, 4, 5, 6, 7, okay? So, yeah, alpha is that standard infinite, okay? All right. Well, it's like by definition, right? Well, given, okay? Yeah, the cardinality of this countable infinite set, that's what alpha is, by definition, okay? So, one more definition. No, no, there's no need for any more definition. This will do. Well, then, okay, yeah, yeah. MD, we don't mean medical doctor, okay? That's what it stands for. It's just multiplication factor times divisor, right? Just making a joke. Okay, I'm looking at the other whiteboard to see some pattern. Okay, so Let's make one more example, okay? So maybe not. Okay. All right. Okay. We'll give it a shot. Right. So yeah, mathematical proof is a beautiful narrative. Okay, it's also beautiful language. Kind of quasi English, quasi mathematics. Okay, the proof is something really cool. Okay, so it's a beautiful language, art. All right, metaphysical art. All right, so okay, all right. I think I got something. Okay, so n over md. All right, n over md. So that's like m times. Okay, okay. Yeah, this is easy. It just takes some time. Okay, it's not like dealing with prime numbers. All right. Yeah. Okay. And we make one more assumption here, okay? So multiplication factor, yeah, because if you is multiplication factor multiplier is just one, pointless, right? We'll assume further assume m is more than one, okay? So, okay, by natural number we mean positive integers, alright? So okay, so m is equal to m minus 1 plus 1, okay? So I think that's, we're gonna take 5 minutes break, okay? So I want you to figure this out, prove this thing before I do, okay? I give you a hint, right? M is equal to m minus 1 plus 1, okay? I think that's the key to this proof, alright? Go ahead, plug this in, okay? See what you got, alright? I think that's the key to this proof, okay? So, okay, yeah. We'll take 5 minutes break. Yeah. And another method to resist any virus like coronavirus, flu, influenza, cold virus. Yeah, if you kind of feel cold, yeah, put some wear clothing on. Okay, extra layers. Also, yeah, boil water in the microwave, right, and drink it. Not too hot. Okay. Yeah, just boil glass of water 2 to 3 minutes, and when it cools down, yeah, drink it. Okay. If you give your body some hot fluid, it really hits your body up. Okay, so exercise, diet, healthy fresh vegetables, fruits, okay, vitamins, alright. So yeah, I do take vitamin gummies, not vitamin pills, but vitamin gummies, okay. So it helps, okay, and have some religion too, okay. So yeah, believe that, pray to God. I always do for myself, my friends and families, okay. So you'll be fine, okay. Shutting down the parks, that's bad idea, okay. They don't know. There's all these politicians, okay? They don't understand science, okay? Your body have to be active, okay? To strengthen the immune system, your body needs fresh oxygen, alright? This lockdown method, that's a bad idea, okay? They don't understand science. They don't understand biology. And scientists, they're too afraid, right? Maybe too busy. They cannot speak up, okay? I'm an amateur scientist. I'm also politician wannabe, okay? Yeah, so I can say tell you all this stuff. Yeah, but yeah, nobody's watching this, right? I mean, if you are watching this, you are somebody. Okay, thank you. All right. You maybe just Google YouTube employee. You are here because you have to. I don't know. Maybe you are working overtime. You watch this during the weekends as a Google YouTube policy compliance. officers. I don't know. Okay. Or maybe you are here because you want to be. All right. Maybe I never met you. Maybe you're my friends and families. I don't know. Okay. But no matter what the case, thank you. Okay. Yeah. Thank you for your time and your love. Okay. Your efforts, your labor. All right. No matter who you are. Okay. We'll take 5 minutes or 10 minutes. Okay. So we have 1 hour left. So. Oh, We're back. Yeah, I'm boiling eggs. The boiled eggs that I peeled a couple of days ago, they were all went bad in my refrigerator because I put in this used container with this leftover food particles. Okay, so it all went bad. Like Americans say, there's no crying over spoiled eggs or spilled milk. So I had to go back to Walmart and purchase another score or dozen of eggs, and I'm boiling it now. Yeah, humidity is also important. Okay, so take a tepid, lukewarm bath. All right, because virus don't do very well in humid environment. Lysis. Okay. Yeah, have some humidity. Drink a lot of water. All right. So okay. Yeah. You know what? Let's not use juxta notation. Why? Yeah, it's kind of brand new. It's pretty much same as set union. Okay. Yeah. Let's not confuse our fellow mathematicians. Okay. Just set union. Okay. So singleton. Okay. Yeah. I prefer using juxta notation, but just let's give some love to our fellow mathematicians. Okay, just unionize singletons set of one element. Okay, so okay. Now, oh boy. Okay. Yeah, I'm not quite getting it. Okay, so I mean, what I wanted to show is that let's give it a shot. And doesn't quite work that way, huh? Okay. Not as easy as I thought it would be. All right, so yeah, forget about this approach. So, all right, I is just natural number. Okay, we're gonna categorize I in terms of n. All right, so I can be multiple of n. Okay, so uh, boy, okay, n is union of, let's say, j from uh 1 to m. We have remainder set. Okay, so we actually j from 0 to n minus 1. Okay, remainder set. All right, so what is remainder set? How do you define remainder set? It's like it's a modular arithmetic, okay, or row algebra that we call it here. Uh, it's remainder, right? Okay. row algebra and then Boolean hybrid, also known as row algebra, known as modular arithmetic, and Boolean hybrid, also known as Iverson bracket. Okay, so okay, here we go. hmm We may have to continue tomorrow, right? Because this is a lot. Yeah. Okay. Okay. Oh boy. For video allowance, let me just continue on this. Okay. So, no, no, it's too much. All right. Yeah. We may have to continue tomorrow. Okay. There's a lot in this. Okay. You have row algebra. You have Boolean hybrid. Row algebra is like remainder, right? Modular arithmetic, and Boolean hybrid is like Iverson bracket. Okay. It's kind of, yeah. There's a lot to this. Okay. We may have to continue this tomorrow. All right. So. Anyways, we'll take 5 minutes break, okay? So, okay. Whew. So basically, we're gonna decompose I into, we're gonna categorize I, this number, all right, into this modulo arithmetic fashion, okay? And then we separate the n over d, okay? Okay. This is gonna take a while, all right? So, but intriguing. We'll take 5 minutes, okay? How interesting. Very. Yeah. We may need a couple of whiteboards, okay? So, but yeah, tomorrow we'll get to this, okay? So, Okay, we are back. We got some erratum because did I tell you a couple of days ago? Like, I mean, if you're a student not accepted by Harvard, Yale, Stanford, MIT. By the way, that's me too. Okay, yeah, I did apply. They didn't accept me. Okay, so does that mean we are less than those people who got accepted by those big schools? No. Okay. Maybe you're busy, okay, doing something else like musical instrument or your rock band or sports. When it comes to me, yeah, I was busy doing something else like humanology, mathematics, but none of those were published. Yeah, I practice martial art, but it's not on record because I just learned from my friends and learned from these Chinese old school martial art movies, and I didn't go to some state competition, became a champion, trophy. No, just informal learning. Okay. Though I have some friends who went ahead and won some champion state level. Okay, in martial arts. Okay, and they told me very good martial arts. Okay. Yeah, but none of the things that I did, yeah, it was not on record. It's more informal between friends or by myself. So yeah, it doesn't quite record it so that I get accepted by MIT, Harvard, Yale, Stanford, Berkeley, whatever. Okay, so yeah, I went to University of Wisconsin. Okay, and I got good education there. Okay, so no matter what school that you go to, whether it's big or not, it doesn't matter. Okay, you learn something, and they do provide good education, right? So that's all that matters. Okay, so just wanted to correct that. Okay, what I said a couple of days ago when we talk about college market. Okay, all right. We grab another whiteboard. Okay, and then we get back to the basics. Okay, I'm going to tell you something about row algebra. Okay, it's ampersand in some computer program language. Okay, just ampersand. Okay, remainder. Alright, but so yeah, row Greek letter row for remainder. Why? But there's a lot to it. Okay, so I'm not sure if it's buried in this 200 lost episode or not, but I'll just give you the basics. Okay, so let's erase this, guys. Okay. Okay. So yeah, it's modular arithmetic was more efficient notation convention by far. Okay, so but let's give some love to traditional mathematicians. Okay, so congruence, right? This Gaussian modular arithmetic. Yes, parental figure. I get it. Okay, so okay. Okay, it's too bulky, right? Yeah. And we came up with better notation convention than this. It's just too inefficient, okay? And it gets in the way. Gets in the way, okay? With very highly inefficient notation convention like this, you cannot get very far. Why is wasting our energy and time? Okay, so in computer programming language, yeah, you have this ampersand symbol, percentage, okay, to denote the remainder, right? So we'll go like this, okay? If you divide 1 by 3, what's the remainder? 1. If you divide 4 by 3, what's the remainder? 1. Okay? So this remainder operator, like in some other computer programming language, they use mod or ampersand. Okay? Yeah, we just use row. Okay? It's easier to write. It's Greek letter R, row, for remainder. Okay? So that's what row algebra is about. Okay? So now, we construct an infinite set. Okay? Infinite set. Three R one is all the is set of all the numbers. We don't deal with negative numbers. Okay? Deal with all the non-negative numbers. Okay? This is set of all the non-negative numbers. When you divide by 3, remainder is 1. Okay? So okay? So how do we express this in algebraic language? Alpha infinity, okay? Yeah, this Boolean hybrid term, okay, Boolean term, okay, so it's also known as Iverson bracket. I'll explain to you, okay, so, okay, to generalize this, uh, some divisor, we are dividing by 3, right? And you have some remainder, small r, okay? Okay? Yeah. So that's row algebra and also Boolean hybrid theory. Boolean hybrid, also known as Iverson bracket, okay? Row algebra, modulo arithmetic, okay? But it's more efficient notation convention, okay? So that's why we use it. Okay. I'll just give you one small example, okay? Because we cannot spend too much time on this, alright? It's very basic, alright? Okay. Boolean hybrid, Iverson bracket, it goes like this, okay? So, okay. I, okay, go from 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Now, in this example, I row 3, okay? It's periodic function, okay? So, if you divide I by 3, what's the remainder? Alright? 1, 2, 0. 1, 2, 0. 1, 2, 0. Okay? Now, we are looking at remainder 1, right? So, Boolean expression I row 3, is it equal to 1? Yeah, you can use this Kronecker delta if it's 1, if that this Boolean expression is same, okay, is true. Yeah, Kronecker delta, okay, then 0 1 0 1, okay, so is this 1? Yeah. Is 2 1? No. Then you give it 0. Boolean, okay, true or false, okay. Is this 1? No. Okay. Yeah, that's this Iverson bracket or Kronecker delta. Yeah, I learned about Iverson bracket, okay, in Wikipedia, a particular generation of Kronecker delta, okay. But I came up with it independently, okay. Can't read discovery, alright. Yeah, Professor Donald Knuth, not to be confused with President Donald Trump, okay. Professor Knuth in Stanford University Computer Science Department, okay, he kind of advocated for, and he was generalized, kinda, okay. I mean, he advocated for this Mr. Iverson bracket, okay. Yeah, Mr. Iverson, computer scientist, okay, Turing Award winner, okay, who invented this new programming language, APL, A programming language, okay. There's some female programming language inventor too, like COBOL, right? Yeah, it was invented by female American computer scientists, okay. I don't remember. Okay. COBOL is very beautiful language, very close to natural English, okay. Okay. So that's the basics, okay. So, alright. Where do we go from here? We may have to do it tomorrow, okay. I'm not even still young. It's not even 9 o'clock. Okay, so we may as well continue after 10 minutes break. I don't know. Ah, boy. Okay. So set of all positive integers, I mean non-negative integers, when you divide by 3, remainder is 1. Okay, it's this, alright? It takes Iverson bracket and modular arithmetic, or also known as, yeah, Boolean hybrid, hybridize Boolean algebra and regular ordinary algebra, okay, and also row algebra, okay. So yeah, it's quite involved, okay. For me, it's very easy because I've been doing this for years, okay. Boolean hybrid, row algebra. I've been doing this for a couple of years, okay. So for me, it's very easy, but for you, it could be kind of culture shock, maybe, okay. So yeah, we're just taking it easy, taking it slow, okay. So for you, all right. Okay. Let me look at the other whiteboard. Okay. You have to speed out one tone. Okay. And there's more to it. Okay. Oh boy. Okay. All right. After this, one more thing, we'll take a break, okay? Alright. So set of natural numbers, okay? No negative integers. Yeah, we're going to include zero, right? Is 3R1, 3R0 union 3R1 union 3R2, okay? You're categorizing all the non-negative integers, natural numbers, into three categories. Okay, we're classifying all the natural numbers, including zero, into three categories. Okay, every single natural number can be classified into three categories. Okay, numbers when divided by three, the remainder is equal to zero, or numbers when divided by three, remainder is one, and numbers divided by three, remainder is two. Okay, if you unionize this to three subsets, each of them, the relationship, yeah, is both complete and mutually exclusive. We talked about that before, right? Disjoint set. Okay? Yeah. An instance of disjoint set. Okay. These three subsets, they are disjoint. Why? Because they are mutually exclusive, meaning they don't have any pairwise intersection. Okay? And they're also complete because if you unionize them, it gives you universal set. Okay? That's the concept of disjoint. Disjointedness meaning it's both mutually exclusive and complete. Okay? I hope I did not erase that episode when we talked about that. Okay, because it's important, right? In set theory. Yeah. Okay. We're introducing new concepts here. Okay, so yeah, we're contributing to mathematics. I think this is quite significant. Okay, so because we're gonna introduce some universal variable. Okay, because this we use three, right? But this can be anything. It could be three, four, five, whatever. All right, so it's universal variable. Okay, so n is equal to okay. So x is kind of universal variable. Okay, so yeah, you can categorize natural numbers in terms of one, two, three, four, five, whatever. Okay, so x is a universal variable. Okay, so this is something really cool. Okay, hmm. I like this. It's very philosophical, somewhat. Okay, yeah, yeah. This is cool. Okay, so it is worthwhile to do this as opposed to Goldbach's condition proof because we are inspired by Goldbach's condition proof, but yeah, we'll get back to it. But because it's such a difficult problem, we will have to put it in the back burner. Why? because along the way we are discovering something per- definitely easier, but perhaps more important. Okay. Yeah. In this cinematographic term, yeah, MacGuffin, yeah, Mr. Alfred Hitchcock, yeah, it's just pretext excuse. Okay, MacGuffin. All right, it's kind of like that. Okay, so MacGuffin. Look it up. Okay, it spells like how it sounds. Okay, you don't understand my accent? Yeah. Okay, I spell it out for you. MacGuffin. MacGuffin. All right, it's a term invented by Mr. Alfred Hitchcock. Okay, in the history of cinema. All right. Yeah, gold box conjecture was our MacGuffin. Okay, some pretext like in Alice's Wonderland. Okay, some rabbit hole. Right, the initiator of inspiration. Kinda. Right. So, okay, we have 2 minutes left. Most likely we just continue. Okay, after 5 minutes break. All right. So let me try to think. Okay, because I really want to prove this thing. Okay. Okay. I think I'm getting it. Okay. So it's gonna take some long time. Okay, because it's quite involved, but it's mechanical. Okay, it doesn't take too much creativity, but it's gonna take some time because there are a lot of steps. But I'm kind of getting it. And okay. So x can be any number. It can be one or whatever. Okay. Positive integers. All right. So okay. So we pick and choose x for our needs. All right. So and we equalize x into 2D. I think. I think. All right. So all right. We take 5 to 10 minutes break and we get back to this. Okay. So all right. See you soon.